All right.
Okay. Yeah.
By the time, what you can do, start with this question. First, write it down. So that at least first you will do it by yourself, then I'll discuss it. This is the last question from this topic, Young's modulus, and we'll start with other moduli. So just write down this question, then I'll discuss this. It's a very easy question though. Just let me know what is the total elongation of the wire coming.
Ma'am, is the same material of wire used for both the cases?
Yes, yes. In this question, no?
Yes, ma'am.
Same wire is passed over the pulley. The wire that is passed is same. So the elongation, you just get the value, you can double it. I'll draw the figure also. See, let us discuss now. This question is like, this says that when a weight W is hung from one end of a wire of length L, the length of wire increases. This length of the wire increases by L. If same wire is passed, if some wire is passed over a pulley and two weights W each are hung at the two ends, what will be the total elongation of the wire? Total elongation you have to tell. It means delta L, complete delta L that you have to tell. See, if at the end of wire weight W is hung, the force that will be used over here, this is W, right? Now, when we are calculating the Young's modulus will be FL by A, and this change in length, what is the change in length? L, so small l. Because the elongation to us is already given as L, that's why I'm putting this as L, right? So actual formula will be now W, because the force is given as weight and delta L is L. So this becomes WL by A small l. Now see, this wire, this is passed over the pulley. You must have done pulley problems in class. we have already done this in Newton's law. So when we started this Newton's law, we had done these pulley problems. But in any ways, we are not going to use it the way we had done it in Newton's law, because here acceleration, all these terms won't be included. It's just that you should know how to have a figure of pulley. So see, now W weights are there, right? Now see, when this entire length was L, so how much each section of length be? L by 2. Do you understand? This is the same wire that is being passed over a pulley. It's just that a single straight wire was there, from which here you have pulled it and connected to a rigid end. That becomes L by 2. So now what is the Young's modulus in this case? That becomes WL by 2, area and the small l. Understood? This length, which was earlier L, this becomes L by 2. So we can equate both of these Young's modulus because material is same, as you were asking also, Harsha, material is same. So when you are equating it, WLAL, this becomes equal to WL2A. Let's write this as some delta L, because otherwise it will be exactly the same. Right, A delta L. So A cancelled, WL cancelled. How much is left? Delta L comes out to be L by 2. So see, this is the elongation in which part? Our answer is not L by 2. Just be careful here. Just pay attention here, class. L by 2 shouldn't be your complete answer. Though this is coming L by 2. Why isn't L by 2 our complete answer? Look here. When I have taken L by 2, L by 2 is just for this wire, right? It means the elongation produced in this wire is L by 2. Elongation produced in this wire is L by 2. So when we are taking total elongation, so the total elongation will become L by 2 plus L by 2. That is ultimately equal to the change in length. So answer will be the same. And why is your answer coming same? Because the material is same and the wire is same. Length has also not decreased. That's why we are getting the same answer. Write it down, then I'll start with bulk modulus now. Bulk modulus and shear modulus, these two moduli are left. Young's modulus we have discussed. Now all the moduli are similar. Once you are thorough with Young's modulus, other moduli of elasticity are easy to deal. Yes, class. Now coming to bulk modulus. So what was Young's modulus? Young's modulus was I have told you know modular of elasticity. When we had seen Hooke's law, the stress by strain became equal to the modular of elasticity. So depending upon the types of stress and types of strain, you will have different types of modular of elasticity. So when there was a change in length, we had Young's modulus, longitudinal stress by longitudinal strain. Bulk modulus is basically normal stress, or you can say not normal stress. This will be volumic stress. Volumic stress we had seen, no? This will be not normal stress. This is actually volumetric stress. So this is volumetric stress to volumetric strain. Why normal was also fine for that? Because ultimately this is perpendicular. The force that gets applied here is perpendicular. That's why. Otherwise, no. Volumetric strain. Anyways, formula now see. Yes, class. Here, volumetric stress, the formula will not be force upon area this time. We, for bulk modulus, we use a different formula. That is the pressure that is applied, no volumetric stress. This is actually the pressure that is being applied on the volume. This force per unit area is actually the pressure that is applied. So we use the term pressure. And what is volumetric strain? Volumetric strain was change in volume by original volume. So here also change in volume and original volume will go up. This is the formula with just addition of this negative sign. And why are we putting this negative sign? Because see, this is compressing it. All the forces are applying and making the size get decreased. So volume here is decreasing. Volume is decreasing. Then one term you have compressibility. Compressibility means how easily the material can be compressed. Like if the compressibility of a material is very, very high, then a little force is required to compress the object and change its shape. All right. So compressibility with the normal literature term also you can relate it. There is not a different meaning to it. So compressibility of a material is a measure of how easily it can be compressed. The formula is also very simple. Formula is simply we represent it with the help of K. This is basically inverse of bulk modulus. K is what? K is compressibility. B is bulk modulus. See SI unit. Here also again SI unit when we are talking about volume divided by volume will be unitless. So entire SI unit will be depending upon pressure. So that is pascals. Here this is inversely proportional, right? So SI unit will become inverse of Pascal. That is pascals minus 1. Let's see one or two questions based on bulk modulus also. First write down the theory part. Plus, this question I'll directly discuss because see, it has a concept from fluid mechanics and we haven't done fluids. This is that average depth of Indian Ocean is 3000 meters. Calculate fractional compression, that is delta V by V of water at the bottom of ocean. Bulk modulus is given, delta V by V you have to calculate, height is given. So which quantity is missing for calculation of delta V by V? You have bulk modulus, you have delta V by V, you do not have pressure, right? Plus, so pressure is missing. So how will you find delta V by V? Because pressure is not there. Had we had pressure, we would have directly kept it in the formula of bulk modulus and we have directly obtained this. This is basically telling, let me brief you with this, just a very slight concept. Otherwise, you have a proper derivation in fluid mechanics. We start only with this. See, this is just, I am taking a rough diagram for explanation. Suppose this is the height which is taken as 3000 meters. Now there is a formula for pressure exerted by the liquid column. When you have a liquid column, if I'm taking a pressure at a particular point, suppose I'm taking a pressure at that point. So entire height, that is 3000 meters. That pressure exerted by this entire liquid, this is actually given by the formula H, height, rho, density of the liquid, G, acceleration due to gravity. We have a complete derivation, so do not worry about this. What is density of water? This you should already know, class. It's 1000 kg per meter cube because this will be used everywhere, not for your just class 11th. For class 12th also, everywhere you should remember the density of water at least. And if you are calculating the density of water in CGS unit, this should be 1 gram per centimeter cube. This is how you have to calculate density of water. And this you have to remember, class. Any day I'll ask you the density of water, SI and CGS, both you have to remember. Now see, bulk modulus was what? Minus P delta V by V. Now we have the formula. So delta V by V is actually equal to H rho G divided by bulk modulus. This is what we had to calculate. See, pressure we have kept it from here. Pressure we have kept it from here. Delta V by V, we have to find it out. Now see delta V by V. Now this is not a tough task. You can calculate delta V by V. Height is 3000, density is 1000, acceleration due to gravity is 10.
Don't consider the minus.
Minus sign you won't consider. See, minus sign, even if you put that, is just telling you that volume is decreasing. It's a decrement in the fraction. So that's why you can neglect. I told you, no, negative sign is just telling you that volume is decreasing. That's why. So this negative sign here is also saying, if you put a negative sign, that with or without that also, it shows that volume is decreasing because of the pressure. So this is 2.2 into 10 to the power 9. I again do not remember this answer. Just check whatever answer you people are getting. 1.5 something should be the answer for this. Because it is 3 and 2.2 something. These 10 will be cancelled. 6, 7. Write it down. Just remember, this is just an additional concept from your, because when you're in your exam, entire syllabus comes. So this portion will be dealt when in your before your exam begins. So that's why these types of questions are there which are interrelated. It was a good question. That's why I discussed this. Otherwise, do not worry about this much. We'll discuss it in detail. One more question we'll discuss right now. See, this question says that if normal density of seawater is 1 gram per centimeter cube, what will be its density at a depth of 3 kilometers? Given compressibility of water is 0.00005 per atmosphere. See, 1 atm is equal to 10 to the power 6 dyne per centimeter cube. This I would suggest you if you could remember, because in this question it is given, and most of the questions it will not be given. What is the value of density given? 1 gram per centimeter cube. How much is the height? 3 kilometers. So that becomes 3 into 10 to the power 3 meters. Then K, compressibility. So K is given 0.00005. 4 now, 1, 2, 3, 4. 5 per atm. Because see, the way we have pascals, no, is the SI unit of pressure. One more unit of pressure that we have is atm, atmosphere. Also, you must have heard of bar. Bar is also pressures SI, pressures unit. So likewise, we have atm also. So that is what it is saying, that 1 atm is equal to 10 to the power 6 dyne. This atm, no, this is actually pressures unit. The way we have pascal, instead of giving it as pascal, it has given it as atm. That's why compressibility, which is inverse of it, is becoming per atmosphere, atmosphere inverse. Question is, we have to find out density. C class. No, density is given. What will be its density at a depth of 3 kilometers? Here again, we'll use the formula. P is equal to H rho G will be used again here also, because without that, we'll not be able to calculate. Look here. Pressure is equal to H rho G. Height is 3 into 10 to the power 3. Density is 1 gram per centimeter cube. So we have to convert this. We'll use 10 to the power 3. And this is G is 10. So this becomes 3 into 10 to the power 7. This was given in how much? This was in meters. This was density 1 gram. So we have written it SI. So this is in SI unit, pascals. All right. This is the pressure. Now see, for bulk modulus can be written as 1 by K, right? So bulk modulus can be calculated as 0.0005. This will be ATM. This will be in ATM. Okay, so we have to have the answer in CGS unit, I think, because this is converting this also in CGS unit. And this is also in CGS. So instead of writing this as 3 kilometers, we should write this as 3 meters. C class, are you getting my point? This is also in CGS unit, dyne per centimeter square. This is already given in CGS. So ultimately, this is expecting the answer to be in CGS. In such situations, try to use this. So we have converted the height in meters. It's better. See, height in meters is 3 into 10 to the power 3. For converting it into centimeters, divided by 2. So that becomes 30 centimeters. So we'll put this here also. Yahan pe bhi. Height is 30, density is 1, G is 10. G also we have to write it in CGS unit now, because this we are writing, this value of G is 9.8 meter per second. C class, when we are writing meter per second, value of K 0.0. Yes, see, value of K is already given in the question. Look, that I have not written. When I am saying the value of K, this is saying compressibility. Compressibility, which I am saying, compressibility is already given in the question. Yes, this is the same K. Yeah, right. This is the same K. All right. This is the value of K only. Compressibility, inverse of bulk modulus.
How does it become 30 centimeter?
How much it is?
How does it become 30 centimeter?
See, this will be, we have taken this, no, this will not be 30 centimeter. I've written it wrong. This will be, the zeros will be added up. That will become we'll have 4 more zeros, not 30 centimeters.
We'll multiply by
This
10
will
raised to-
become 2 more zeros will come. So this would be, I had written it as 30. This won't be 30 centimeters. 3 kilometers are there, no? So we'll multiply it by, so 5 more zeros will be there, no? So 3 into 10 to the power 5 centimeters. Because we'll multiply 10 to the power 3 we add, then 10 to the power 2. So that becomes 10 to the power 5 for conversion. So this becomes 3 into 10 to the power 5. And acceleration due to gravity, this is also meter per second square. So we'll use this as 980, I think this comes. So when we use it in a CGS unit, 981. 981 centimeter per second square. Just check. I think this should be, this is what we generally use, 981 or 980. So when you will put in the value, this becomes 3 into 981 multiplied by, see, 3 into 1. This is 981 into 10 to the power 5. So 981, this will be 3, 4, 1. Then you have 9 and 1 plus 2. 2943 into 10 to the power 5. This should be the value. Now you have bulk modulus from here, right? So from here, we'll calculate the value of pressure is there, bulk modulus is there. We have to find out delta V by V from here. What will be its density at a depth? See, why delta V by V? Because the material that is used here is seawater. All right, class. And whatever, since the SI unit and the CGS unit both are 1. CGS unit for the density of water is 1. SI unit is 1000, but CGS unit is 1. If something is 1, tell me density is equal to mass by volume. Right? Density is equal to mass by volume. Now look here. If this density becomes 1, then mass will be equal to the volume. Right? This will be exactly equal to the volume. So here you are basically trying to get the value of delta V by V. So from here pressure can be calculated, and then delta V. Once you have pressure, once you have bulk modulus from here, this will also be 2 something, 2 into 10 to the power minus something. So when you will put it in the formula minus P delta V by V, you will get the value of volume. And whatever is the volume, that will be the exactly value of density, and that will be exact value of mass, because this is standardized for water. Write it down, check what is the exact value coming. Till here I've solved. Bulk modulus, reverse it. Check what is delta V by V coming. Write it. Then one more topic I'll do today, shear modulus.
Ma'am, after finding delta V by V, how do you find density?
See, whatever this basically, this is saying, when I was saying that this is density is already mentioned, it is saying normal density of seawater is given. What will be its density at a depth of 3 kilometers? When we use this formula, no, density is equal to mass by volume. Here you basically get density is 1 gram per centimeter. So volume, mass, density, volume and mass will be the same, right? Volume and mass will be the same. So from here we are getting the volume, and that new volume, whatever volume you get, that will actually be equal to the density itself. I'll tell you this. First, do one thing. First, calculate all of you and let me know what is the value of delta V by V coming directly. Then I'll just discuss the solution with you. I let me calculate it and let you know. Wait. Yes, any values, class?
Ma'am, I got 14715.
Wait, let me write. Delta V by V you're getting.
Yes, ma'am.
Delta V by V, how much you're getting it?
14715.
14715. This much?
Yes, ma'am.
Okay. Let us assume, please, someone else also cross-check and let me know. I haven't calculated this. See, this is your final answer itself. Now, how is it your final answer? No. In simple words, you can remember that density is equal to mass by volume. Here, whatever is the volume and whatever is mass, both are same. Volume and mass both are same. So the value of density is also not changing. Or one equation also we have, because see, this is technically not correct. This is just I am telling you to so that you people remember it. We haven't done fluids mechanics. This question is better dealt in fluids mechanics. There is a formula which says that dp over rho when you integrate it. I don't think so the syllabus is this is there in your syllabus. Integration of rho over rho, that is integration of density from 1 to whatever value of density is given, this comes equal to change in volume. So by this formula also, when we put in the value, when we integrate, ultimately this says that density becomes equal to volume. This is the case when your starting number is 1. That is the density of sea water or any water. This is 1 gram per centimeter cube. So this, since we have not done this, and I don't think so this is in your syllabus also, I'll have to check it when we'll be doing fluids. That's why I'm saying you remember it in such a manner that density is equal to mass by volume. Now mass, volume, density, all are not changing because here the density's value is 1 gram per centimeter cube. So volume is equal to the mass, and mass is equal to the density of normal water. See, this density is of sea water. Look here like this. Density of seawater is equal to mass by volume. This is given to you as 1 gram per centimeter cube. So volume is equal to mass. Fine. Now, density of normal water is equal to mass by volume. Since this mass is already equal to the volume, and this density is also 1 gram per centimeter cube. This could have been something else, density of seawater. This is in this question specifically mentioned as 1 gram per centimeter cube. That's why we are saying, since both the densities are same, both the masses are also same, both the volume is same. And whatever fraction you are getting, that is actually coming equal to the density. But actually, what is the formula? There's a proper derivation which says that change in density comes equal to the change in the fractional volume. Here you are properly integrating it from rho to rho dash, whatever is the value. We have one more formula of pressure, that is P naught plus rho Hg. We start with this formula. P naught by P becomes density remains, G is constant, G and H get eliminated, and 1 plus C constant term also comes. So that integration, I don't think there is there in your syllabus, but formula usage are there. So I think if till here also you people have solved it, delta V by V, that is equal to the answer almost. Is it clear now, Harsha?
Ma'am, this is applicable only for water.
This is
Only for water, or
only for
can
water, because the density of water is only 1 gram per centimeter cube, not for any other material. All right, not for any other material. That's why I'm saying this is very important, that this has given seawater is also 1 gram per centimeter. So just this question is very specific.
Okay.
All the solution for which I'm telling is just specific for this question, because here this is also 1 gram per centimeter cube plus water is used, and in most of the cases no water only will be given, like here also water was given, because density is standardized for water. You do not have to remember density for any other material, but for water, SI and CGS you have to remember. That's why I'm saying this is important. This you people should remember. It is helpful for tough questions like these also. Now clear, Harsha?
Yes, ma'am.
Write down the solution. This you people have done, no? Just write down these extra things so that you remember when you are revising.
So the final answer will be in CGS, right? Gram per centimeter cube.
Final answer will be in CGS. Actually, in this you won't get any unit because delta V by V is there. But when you are writing it for density, when you equate it, that will be in gram per centimeter cube only, because we have converted everything into CGS. Because 2 units were given in CGS already. That's why. Answer will be in CGS itself.